Welcome to day 5, periodic functions. We talked about periodic functions last class when we did the graphs of sine and cosine. We said sine and cosine were periodic because they do repeat over and over and over again horizontally. So a periodic function repeats horizontally at regular intervals. In other words, if it repeats, it's got to be the same amount of x every single time that it repeats. So it's basically making a rubber stamp of what the graph could be. So when we look at the graph, and I'm going to pick green, I'm going to make it a little bit thicker and be like, I'm going to identify one period. Okay, so I'm going to draw one cycle. I'm going to start here on the y-axis and draw what would be one full cycle of this graph, and I notice I come right here. So this is its period from here to here, and that is equal to one period or one cycle of this graph, and that in this case is equal to 4 pi. It's easy to start on the y-axis to do this because then whenever you stop and do one cycle, that x value is the period. So I'll do the same thing over here. I'm going to start here. I can go from here to here, from this point to this point, and this is one period, and that value, I gotta go thinner, is equal to pi. But a period could be not just from the y-axis. I could have taken from starting here and drawn one cycle, and from here to here, this is still pi is the length on that x-axis. So it gets a little bit more difficult on this graph because it's more horizontally compressed, but if I start here at the origin and do one full cycle, I end up here. I'll do the same thing over here. And I think for these two examples, you can see that this period from here to here is equal to this number here. It's harder to see, is pi over 2. And then from here to here, this is one period, and that is equal to 8 pi. So last class when we talked about the sine and cosine functions, and again they're periodic because they repeat, we talked about two features called midline and amplitude. Midline is halfway between the maximum and the minimum. And we said we had a formula for that. We said that midline was equal to the max plus the min, or the min plus the max, divided by 2. Add them together and divide by 2. And amplitude is something that is always positive, and is the distance, and distance is always positive, from the midline to the maximum or the minimum, doesn't matter, distance is distance, and our formula for that is that our amplitude is equal to the max minus the midline. Our amplitude is equal to the midline minus the minimum. You could go the other way. It's just that if you ever get a negative number for amplitude, you got to realize that it is positive. So we're going to identify period, midline, and amplitude for all these four graphs. We kind of did that last class. The only thing we didn't identify was the period because it was always 2 pi. But this isn't too hard. You can look at this graph and say, well, my max is equal to 3, my min is equal to 1, 3 plus 1 over 2. So my midline is y is equal to 2, and I could draw that across the page. My amplitude is right here. This is my midline. My amplitude is equal to 3 minus 2, so my amplitude is 1. And the period again, I'll make it a little bit thicker. I can start here and just draw one period of this graph, and I can realize this is one full cycle, and that is pi over 2 is my period. Going to the next graph, I'll do the period first. If I start here at the y-axis of of 2, and draw one full cycle and stop again when I get to y equals 2 going in the same direction, I can see that this is the period, and that is equal to 4 pi. That is the period. I have a max equal to 5. I have a min equal to -1. So my midline is going to be 5 minus 1 over 2, 4 over 2. I get y equals 2 as a midline. I think that's kind of where I do the period. And then my amplitude is this distance here. So my amplitude is equal to 5 minus 2, and my amplitude is equal to 3. So I think this one's a little bit more difficult to start on the y-axis to figure out my period. Because if I start here at where y equals -1, I'm never going to get back to -1, so I'm going to maybe start here at this minimum value. I'm going to draw one full cycle until I get the minimum value. I could see that this period here is from -2 pi to 6 pi, or the distance is 8 pi. I have a max equal to -0.5 and a min equal to -1.5. And I can do my midline is equal to -0.5 minus 1.5 over 2, which is -2 over 2. I get my midline equal to -1. And then my amplitude, well, here's my midline. My amplitude is this distance. So my amplitude is equal to -0.5 minus a -1. So my amplitude is going to be positive 0.5. Same thing over here for this next one. Again, I can't start here at y equals 1. I will never get to a full period, so maybe I'm going to start here at this minimum point to that minimum point, and you can see, again, I get 8 pi. I could have done anywhere. I could have done from the max points. I could have done from here to here, from -6 pi to 2 pi. I still would have had a period equal to 8 pi. And then I could do some mins and maxes. My max is equal to 4. My min is equal to -2. So my midline, 4 minus 2 over 2, 2 over 2, which is 1, y equals 1. So right here is my midline of y equals 1. So my amplitude is this distance here, so my amplitude is equal to 4 minus 1, so my amplitude is 3. So that's just noticing some features on a graph. Okay, we're going to decide what the period is by tracing it to see how far it takes to repeat itself, and we're going to play the even, odd, or neither game by looking at the symmetry, even being reflected over the y-axis, or I get opposite x values and I get the same y. Odd meaning I get a rotation of 180 degrees, which means when I have opposite x values, I have opposite y's. So to trace this, I'm just going to start here at the origin, and I trace, and it looks like right here, that would be my rubber stamp, and this is the pattern I can repeat over and over and over again. So I get a period equal to 2. And the one thing I could do is see, does it fold over the y-axis? It does not. I could rotate it and realize it's the same picture either way. But if I look carefully, that when I do, what do I want to choose? I could choose this one right here, this point here, and this point right here, that f of -0.5 and f of 0.5, they both equal 1. Let's call that space up 1. So, well, no, they're not both 1. -0.5 was 1. Positive 0.5 was -1. So, as you can see, opposite x's have opposite y's. This is an odd function. The next one, I'm going to trace. I can start here. I could do one trace of this, horizontal and then a V. It'd be a horizontal and a V over and over and over again. So I get a period equal to 3. And if you wanted, you could start here, and you could have done this as a period. That's another way to do it, just this little trapezoid, and you go from 5 to 8, and that's still a period of 3. If I take 2 points on this, let's say I take this point here at 1 and this point here at -1, so I have f of 1 is equal to 1 and f of -1 is equal to 0. That's not doing opposite or the same, so that is neither. The next one I can trace, I could start here at the origin and kind of go down, back up, down here, and I could see the period is equal to 2. I could have done the period from here. I could have just started here at the top here and done it this, kind of like a little check. You can still see the period is 2. Excuse me, the period is, period is 2. But when I figure out if it's even or odd, let me grab a different color or a different thickness, I could see that f of 0.75 is maybe equal to 0, 0.75 being right around here, and f of negative 0.75 is equal to right around here. This may be about 1. So again, this is neither. And this last one here, well, this is an easy one to see, the period. The period is obviously just one of those half circles, semicircles. That period is 1, and hopefully you could see that it is just repeating itself over and over the y-axis, and this is an even function. Symmetric over the y-axis, all these semicircles. Now, are these periodic? Do these functions repeat horizontally? Well, let's see. I see the number is 157, and when I say repeat, that means it has repeating y values. And I see 157 again. I notice that happens pretty regular. 0 through 3, 1 through 4, 2 to 5. So I'm seeing that the period is equal to 3 because it repeats regularly. And over here I see 0, 1, 0, negative 1, 1, and then it goes 0, 1, and I'm unsure what it does here. Maybe it repeats, maybe it doesn't repeat. So I'm going to say it's not periodic if I can't see that it's actually repeating. I'm unsure. Now these next ones, I say they are periodic. We have to identify the midline, the amplitude, and the period. Well, again, I see 12, 13, 14, 12, 13, 14. I see they're happening pretty regular. 0 through 3, 1 through 4, 2 through 5. So I see the period is equal to 3 because they do repeat. Well, according to the numbers I have, and that's all I can use, I have a max equal to 14, a min equal to 12, so my midline is equal to 12 plus 14. That's not good. Let me erase. 12 plus 14 over 2, which gives me 13, so my midline is y equals 13, and my amplitude is equal to my max of 14 minus my midline of 13. That gives me 1, so I got an amplitude equal to 1. The next example, I do see this 5, 3, 2, 3, 5, 3, 2, 3. I see they do repeat. 1 to 41, 11 to 51. So my period is the difference between these. So 41 minus 1 or 51 minus 11. So my period is equal to 40. I see a max equal to 5. I see a min equal to 2. So my midline is 5 plus 2 over 2, or 7 over 2. So I have a midline y equals 3.5. And my amplitude is my max of 5 minus 3.5. So my amplitude is 1.5. So now we'll look at real-life examples of periodic functions. A real-life example of periodic function is a Ferris wheel. If you ride a Ferris wheel over and over, going round and round and round, your height from the ground is going to repeat at regular intervals if the Ferris wheel is holding a set pattern. So we have this giant one in London called the London Eye, 450 feet in diameter, one rotation around in 30 minutes. It goes slowly so you can get to the top and see the whole city. Okay, so if you hop on at time equals 0, you're going to ride it for 2 full turns, and we're going to go through this problem. But the big thing, I'm going to make it very much a standout. All Ferris wheel turn counterclockwise. In this class, they always go counterclockwise. So when you're here at the minimum, when you first get on, it's always going to go this direction. This point here is the midline. Still going counterclockwise. Then you have the max. Oops. Let me hit pause. Okay, when this happens, hopefully it'll let me cut out of here. Let me see what's going on. Let me hit max. Let me get all this. Okay, I'm back. Okay, so then you go to the max, you go some more, you get to the midline again, and then you get to the minimum. Let's talk about positions on a clock. When you're at the bottom of the minimum, this is 6 o'clock on a clock. At the max, it's 12 o'clock. When you're in the midline going up, that's the 3 o'clock position. When you're in the midline going down, you're at the 9 o'clock position. Let's see if I can minimize this and see if I can get my thing back. Okay, I'm going to pause. Sorry about that, but sometimes it happens when I get too close to the top. So all Ferris wheel goes counterclockwise. The bottom is the 6 o'clock position is the minimum. The top is at 12 o'clock. And since we go counterclockwise, when you're at the bottom and you go to the midline, that's the 3 o'clock position, and so on and so forth. I have a little animation here. If you want to click on this on the notes, you can do that yourself. But let's look at this London Eye, because I'm going to put it over here. So at the bottom, we're at t is equal to 0 minutes. Our height is equal to 0 feet. And then we go counterclockwise, because all Ferris wheels go counterclockwise. Since it takes 30 minutes around, we're at t equals 30 minutes to get back to the minimum again of 0 feet. So at the top, we're at t is equal to 15 minutes, and that means we're at a height, and the height of this whole Ferris wheel is 450 feet. Where we're at the 3 o'clock position over here, it takes 7.5 minutes to get there, and our height is only halfway, which is 225 feet. And we're going counterclockwise, counterclockwise. So at this time, we're at 3/4 of the way around, 22.5 minutes. Our height is 225 feet. And again, we're going counterclockwise. If we want to call positions on the clock, this bottom is the 6 o'clock position. This position here is a 3 o'clock position. This is a 12 o'clock position. And this position over here is a 9 o'clock position. The difference between the 3 o'clock position and the 9 o'clock position, 3 o'clock position is the midline or halfway up, going up. And the 9 o'clock position is the midline or halfway up, going down. So you're going to use these values to complete 2 times around the London Eye. So at 0 time, we're at 0 feet. At 7.5, according to what we did, we're at 225 feet. 15, 15, we've reached the top of the Ferris wheel, 450 feet. 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 20, 22.5 minutes, we're at the 9 o'clock position. We're midline again. And at 30 minutes, we're back at 0. And we repeat our process: 225, 450, 225, and 0. So this data here is the height of the Ferris wheel after t minutes of riding the Ferris wheel. And I'm going to plot all this information on this graph. So as you can see, I plotted all those points from what I did from pink, and I'm going to draw my periodic function. Again, this is somewhat of a trig function, so it's got to be wavy to the best of my ability. I kind of missed that dot, but I don't really care. Trying very hard to be wavy. There we go. That is 2 full cycles of this graph. I've noted the max is 450, the min is 0, so my midline, 450 plus 0. Oops, where's my eraser? 450 plus 0 over 2 is 225. If you notice right here, across the middle of the page, I have my midline of y equals 225. My amplitude is this distance here, and this amplitude is also equal to 225. That's by coincidence because I do have 450 minus 225. That will happen when the minimum is at 0. And the period, I'll do in pink, is from this point at the minimum to another point at the minimum. So the period is equal to 30 minutes, which we knew before because that's what we said it took to do 1 revolution. But you could take any points to figure out a period. You could have taken this point here and this point here because they're both on the midline going in the same direction. This will also be 1 period of 30 minutes. So this is what we have when we have a trig function or something that's periodic that kind of repeats itself. We have these features. So let's say the operator of the Ferris wheel of the London Eye has decided to speed it up a little bit. So it's taking 30 minutes to do a revolution. It's going to take 10. So I'm still going to have the diameter is 450. And I think we saw that the amplitude is the radius, half of that 225. And I'm going to make all these details on this graph. So I marked the y-axis. The only thing I'm going to do is I'm going to mark the x-axis. And what I'm going to do, I'm not going to mark off 10 tick marks for the 10 minutes. I'm going to mark off 4 tick marks. 1, 2, 3, 4, and the 4th tick mark will always be whatever the period is. In this case, it's 10 minutes for a revolution, so it's 10. It says I have to do 2 cycles. I'm going to do 4 more. 1, 2, 3, 4. And there's my 20 minutes. And now I can make my dots on the graph. It says, well, you're going to start at the bottom because you're going to get on, and then you're going to go middle, max, middle, and at 10 minutes you should be back at the bottom. I'm going to go middle, max, middle, and again at 20 minutes I should be back at the bottom, and I should draw this graph to the best of my ability to make a wavy graph. The period we already discussed was 10 minutes. The midline is right here in the middle, which we talked before, which was y equals 225, y equals 225, and the amplitude, which is right here, that we discussed on the other page, was also 225, but the amplitude will always be the radius of a Ferris wheel. The midline may or may not. It will be when the minimum is at 0, but when we have this one, the amplitude will always be the radius because I can go this way. And this amplitude here is also 225 because it's right in the middle. Now this next one is a little bit different. It's a different Ferris wheel. We've made some changes. It's bigger, 600 foot. You're going to get on not at the bottom at 0. You're going to bore the platform at 5 feet above the ground. You're still going to make 1 revolution every 10 minutes. And when you start your watch, you're not going to start your watch when you first get on. You're going to start your watch at t equals 0 when you're in the 12 o'clock position, when you're at the top of the Ferris wheel. You're going to make 2 full revolutions, and you got to come back to the boarding platform. You can't jump off the top. You're not jumping from 600 feet. So I'm going to mark the x and y axis to show you what we need. Okay, mark the x-axis, and the fourth tick mark was 10, the eighth one was 20. I went a little bit farther because I know after 20 I'm not going to be done yet. Now because the minimum is at 5, I have to put 5 here on the minimum, and the max is not 600, the max is 605, because I have to be 600 feet higher than the bottom of the platform or the bottom of the Ferris wheel. So I have my midline is going to equal 5 plus 605 over 2, 610 over 2, which is 305. So right here in the middle, I'm going to mark 305. And I'm going to draw this midline across the middle of the page, get the right color. And it says I'm starting at the top. So my first dot is here at the top. Even though I didn't board at the top, that's when I'm going to start my clock. And then I'm going to go middle, min, middle, back to the max, middle, min, middle, back at the max at 20. I could get down to the bottom, so I got to do 2 more dots to get to the bottom. And if everyone is worth 5, then this guy is worth 25. I go draw my wavy graph, and down to the bottom it looks something like that. I have my y equals 305. Y equals 305 is my midline. My period is still 10. My amplitude is from here to here, and my amplitude is 605 minus 305. My amplitude is 300, but we knew that because the radius is also equal to 300. And there we go. You can see this amplitude is equal to 300 either way. My period from this dot to this dot, my period is equal to 10. And those are our details for this graph for this different type of Ferris wheel. Thank you.